Cool. Looks like we are live. Hi, everybody. My name is Jonathan Michaux. I'm a product manager at Gravitee, and welcome to this talk called AI Agents Meet Async API Conversational Interfaces for Event Streams. So, quick background about me. I started off as a computer science researcher. I did a PhD in computer science on formal methods applied to distributed systems. And since then, I've worked in a number of different companies as a back-end engineer and then also as a product owner, product manager, mostly in enterprise software companies like API management, event-driven architecture, ESB, microservices, all that kind of stuff. More recently, I co-authored a book called The Kubernetes Cookbook at O'Reilly with colleagues from my previous company. I live in Nantes in France, which is has this iconic elephant that roams the streets and sprays water over all the children running around. A lot of fun, definitely worth a visit if you've never been. It's a very cool city. So that's me in a nutshell. So I'm a product manager at Gravitee. I've been here for about a year and a bit now, and I'll be talking about a few different things today. One thing I wanted to announce is that Gravitee, we sponsored the OpenAPI, the Async API project, June 4th, 2024. So we're very proud to be partners of the project. Very excited to do that, and I'll talk a little bit during this talk about why Async API matters so much to us at Gravitee and why we think event-driven architecture and event-driven APIs are definitely a thing of the future. So basically, the premise for this talk is as follows. So if you look around at what's happening in AI these days, obviously different hype cycles, different trends, but at the moment, one thing that really is standing out a lot is basically creation of agentic systems or AI agents. And I think this is a very interesting thing as, you know, as someone who's kind of an engineering mindset working in a technology space. The idea of building autonomous intelligent agents or little programs basically that can leverage AI to do tasks on your behalf is very compelling. We're seeing companies like GitHub and Microsoft and Google and others all building out these new agentic frameworks which make it very easy for you to build smart pieces of code that interact with other pieces of software and the outside world. And so basically agentic systems, one of the things they do is they act on the outside world, and they often use OpenAPI to do that. And so that's becoming quite a common pattern, basically, is to use OpenAPI to describe ways in which an AI agent can interact with the outside world. But what we haven't seen much of yet is using AsyncAPI to do the same. And that's the premise for this talk, is basically why has AsyncAPI not yet been described as basically a solution to provide actions to an AI, and while OpenAPI has. So the premise for this talk is really this question, like, what about AsyncAPI? Where does it fit into this? And can AsyncAPI play a similar role as OpenAPI in the world of AI agents? So that's what I'd like to explore today, basically. So with that, the kind of outline of this talk is I want to start off talking a bit about the foundations and context. So, what is all this stuff? Why am I asking these questions? Then just think a little bit about like how AI and Async API fit together, event-driven architecture and AI, what the different use cases are there. And then I'll go into pretty hands-on into something a bit more experimental with some code and a demo to show you kind of basically my first experiments trying to build some of this stuff up. So the starting point, I think, just to retrace a very basic outline of how we got here. So, chatting with LLMs is something we've all experienced now. As a human, you can interact with an LLM through a chat style interface or application and ask questions. Like, for example, you can ask the question, what is Gravitee? And the LLM can answer back something like, oh, haven't you heard Gravitee are leaders in the Gartner API Magic Quadrant, API Management Magic Quadrant, as an example. By the way, you'll see a bit of an issue in some of these diagrams, which is for some reason I've put the brains on the LLM instead of the human. You could argue it should be the other way around, at least for now. So apologize about that. You'll find that as a mistake across a few of my slides. But the challenge with LLM chatbots is that if you ask a question which is about something more recent in the real world, like, for example, what is the weather in Paris? Then the LLM is likely to answer something like, well, I'm just an LLM. How would you expect me to know this? I'm just sort of leveraging data that I've got, historical data, but I can't give you up-to-date live information from the real world. So that's a very good premise, basically, for explaining one of the points I think about AI agents is that So an AI agent is essentially just a piece of software, some code that you've written, but that leverages LLMs in some way, whether those LLMs are built into your code or if they're, you're calling an external service on OpenAI or whatever it might be. That's basically an AI agent or an agentic system. And some of the core parts of what an AI agent does is, first of all, it needs data sources. So it's gonna use data, text, to basically improve its context and understanding of the world and ways to answer questions. It's going to interact with a human, probably in some way, that's going to trigger actions or ask questions or provide some kind of input. And it's going to take actions. Because without being able to take actions, well, the AI agent can reason using LLM and the data and the human interaction, but it can't do anything in the real world. So it needs to be able to take actions. And that's, I think, a key part of what makes these agents interesting, is they're taking actions on your behalf. Now, the big question then is, okay, well, how can an agent take actions in the real world? An LLM is just generating text generally, right? So an LLM itself cannot, invoke a function or call an API or, take some kind of action in the physical world. It's not able to do that. So an AI agent has to use the LLM to its advantage to figure out how to call functions and code in a useful way. And so this pattern basically has emerged now, and people call it function calling. And it's a bit confusing again, because the LLM is not calling functions, but basically what you need to do is you need to explain to an LLM, here are some functions that I have available in my system. Like, for example, there's a function to call to get the weather, and I'm going to teach you how to call it by telling you, figure out what the city is, and then pass me that, as a prototype to a function call, and then you can use that in your own program to invoke a function. So let's take a bit more of a detailed example. Basically, you can teach an LLM to take action through functions by providing, as part of like a system prompt, or even just in any old prompt, a definition of a function. So this is just some, abstract definition of what a function is. So like I'm saying here, this is a function. It has a name, which is get weather. There's a description that can help the LLM sort of understand the meaning of this function. And then you describe the parameters, so that the LLM basically knows, like from the text it's getting from a person, like what way to transform that into something that looks more like a function call. So this one here has a parameter called city. It's a string and it's the name of a city. So basically, if a user enters into an agentic system, what is the weather in Paris? Well, the LLM can infer, okay, this user is asking about the weather in Paris. It can then match this to a function that it has available. So it can figure out that, okay, there is a function here which will let me get the weather, and this is what it looks like. So it can return a data structure that matches a function invocation. So basically here, in this case, get weather Paris. And then your code will receive this back and can use that to say, okay, the LLM has decided this is the function we need to call. And then your code can actually make that action and execute that function, whatever that may be. It might be to just print something to stand it out. It might be calling an API. It could be interacting with an async API in some way, as you'll see we'll do in a second. And so obviously, OpenAPI is used, it seems, quite a lot already in this context. So basically, if I can give my agent a OpenAPI definition that describes a weather API, then that looks a lot like a function. Basically, it's a prototype description of a function that can be called. It's just an HTTP function, but it's still a kind of function. And so you can basically teach your LLM to interpret that. And then if you ask a question like, what is the weather in Paris? Well, then basically the LLM can determine that there's an API which can answer this question, and then tell your agent, here's the function you should be calling, here are the parameters, and then you can actually, in your agent, execute the function and call the external weather service. So here we are now basically teaching LLMs like the meaning of some services that exist and how to call them, and then it can basically guide your agent and tell it, this is what I've determined you should do. So that's great, and that works for OpenAPI, and I think it's basically becoming a very common pattern. But basically the question is, okay, well, what if we gave the LLM an async API definition instead of an open API definition? What kind of actions in the real world could an AI agent take if it has the understanding of functions or actions it can take defined in an async API definition? And this is, the whole premise of this talk, is to sort of think about this and try to understand how this can be done and what it could mean. And obviously, that semantically, an asynchronous API is quite different to a synchronous API because the use cases are quite different. With a synchronous REST API, you're calling and you're getting a response back. With asynchronous APIs, you're in a very sort of decoupled model. You can either produce messages or consume them, but the paradigm is quite different. So it's a very interesting exercise to think about how this could apply. Now, basically, I think so. We're going to talk a bit briefly about Kafka, but you could replace Kafka with basically any event-driven system. It's just a very good use case to use an example here, and think about, okay, how can an AI interact with a Kafka broker described by AsyncAPI? So, and the premise also here for Kafka is that basically data in Kafka is being increasingly productized. So what do I mean by this? We at Gravitee, we speak to more and more companies that are basically have more and more valuable data in Kafka, or they're basically processing and what's the word I'm looking for? Curating the data in Kafka more and more, such that it becomes something that's closer to a data product. And the more value your data has in Kafka, the more likely you are to want to use it in different situations that are maybe more relevant to your business than some of the sort of more lower level data-oriented use cases that Kafka has been known for a long time. And so based on that, basically people want to productize this data a bit more. And productizing means, how can we possibly, expose this to some new developers, new consumers, maybe even external partners. And AsyncAPI obviously is very good at describing Kafka. It's a standard way to say, here are the Kafka topics in my system, which map to channels in AsyncAPI, and you can define the schemas as well and all that kind of stuff, the server URLs and everything you need basically to be able to interact with a Kafka topic. So that's great. And then that raises the next question, which is, okay, let's assume I've described Kafka with an AsyncAPI definition. Now, what can I actually do with that? What are the use cases for interacting with Kafka? And so generally, I like to split Kafka use cases across two different categories. We have analytical use cases. So this is more people that have roles like data engineers or data scientists that are really close to the data, and they're going to be processing the data. So things like stream processing frameworks. They want to be doing visualization, data integration, ETL, like pushing data to data warehouses, pushing data to data visualization tools, those sort of things. And then you have the operational use cases, which are more where each individual event in Kafka has a much stronger, meaningful significance to the business. So typically, you'll see use cases like people using Kafka as a backbone for microservices to communicate, rather than necessarily using synchronous APIs all the time. Or you'll see things where people are processing logs and monitoring metrics through Kafka, and also things like transaction processing, where an important event like literally a business financial transaction could be processed through Kafka. So when thinking about, okay, here's my AsyncAPI definition describing my Kafka broker, it's really interesting to think about, okay, well, if I'm going to use an AI now to interact with it, which of these use cases can I solve? And obviously, these are all very different. So the solutions, the type of actions you want to take, the type of code you might want to generate or whatnot will vary very much depending on the use case. And I think these are all very interesting directions to explore. But there's one that in the short term I've chosen to explore a bit more, which is developer experience. Now, the reason behind this is because developer experience is notoriously hard with event-driven systems. So, it's such a sort of decoupled environment where you don't really know who's producing, who's consuming, and it's also typically just been harder to discover the assets available in an event-driven architecture. And so, David Boyne, who's built this great event catalog tool, talked about this a couple of years ago at AsyncAPI conference, where he talked about how basically of all the different areas in which innovation can occur in event-driven architecture, the discovery phase, is the one of the most valuable, which has been the least developed up until now, basically. And so what discovery means is, let's say you're a developer joining an organization, how can you discover the event-driven systems, the topics, the event streams that are available to you to consume? That is a very sort of unsolved problem, basically, up until now. So I think that's an interesting angle as well to look at when thinking about AsyncAPI and event-driven systems and AI, and how they can all play a role in making discovery better and improving developer experience. So yeah, I think basically before going into a bit of a demo, I think AsyncAPI is very well positioned basically to be the standard way for AI to interact with event-driven systems. If your event-driven system is properly described by an AsyncAPI definition, you should be able to feed it to an AI agent that can use it to implement a form of function calling so that an AI system can interact with your event-driven system easily. So with that, let's go into a little demo. And like I said, I'm going to focus a bit more here on developer experience. So the key thing I'm trying to do here is basically say, all right, let's assume you have a Kafka broker of some kind in your enterprise, or multiple. How can we make it easy for developers to interact with those using a conversational type interface? So actually, to get started, I'll just show you basically what I have running here on my machine. I have a Confluent platform cluster here running on my computer. Now, this could be Confluent, it could be something else. It doesn't really matter ultimately. The key thing is that it's Kafka. And what you can see is I have some topics here that I've defined already. So we have a topic called catalog customers, catalog orders, catalog burgers. So there's 3 topics that I'm kind of interested in here, and you could have obviously many, many more. Now, the first step, the first thing I want to do here is I want to create like a catalog of async API definitions for this Kafka cluster. That's going to help me basically describe these systems in a standardized way such that I can then interact with them. So to do that, I'm going to use Gravitee actually, and you could use other tools as well. But Gravitee has this ability to connect to Confluent and to discover the topics and schemas available there. So basically, Gravitee is an API management platform, but we've expanded it now so we can integrate with other systems and catalog other types of systems and API gateways and event brokers and things like that all in one place. So what I've done here is I've discovered now some topics on my Kafka broker, and I can proceed and basically create those inside the Gravitee catalog, so that now we have 3 APIs that are described here inside Gravitee. So if I go back to my list of APIs here, you'll see not the usual synchronous REST APIs you would see on a usual API gateway, but you're actually seeing federated APIs which match topics on Confluent platform. So if I, for example, select catalog burgers here, you'll see I've got a bunch of information. I've got a name, I've got some description. You can see this came from Confluent platform. And if I go to the documentation section here, you'll see we've actually generated an async API definition that matches this broker and this topic and the schemas. So you can see here I've got information about the server. I've got the channels here with the name of the topic as expected, and I've got subscribe, publish operations which are described, which reference a message as a payload. And if I come down here, you can see the message includes basically schema information about that message. So it says like, what is this exactly? So you can see there are 3 properties: a type, like what type of burger is it, calories, number of calories, okay, the description's not right, and pickles, whether or not there are pickles in this burger, basically. So very cool. So now I have this catalog with multiple async API definitions for each of my topics. So that's a very good starting point, basically, when you're thinking about an AI agent and you want to feed it some information that it can use, right? So let's now switch over to my more the AI part of the demo. I'll just briefly show you what I've actually done here. So I have a little project here in Node.js. And one important part of this project is this definition of some functions. So we talked about functions, function calling as being a way to basically teach an LLM to match, context, user input to function calls. And so the functions I'm defining here for my asynchronous APIs are the following. I've got the ability to list available topics. So as we saw, my async API definitions describe topics. I've got the ability to ask about the schema for a topic. So tell me basically what is the structure of messages on the customers topic, on the orders topic. And I've got an operation here, which is get the last message on a specific topic. So very useful. I'm starting to actually literally interact with the Kafka broker and asking it to read messages one by one. You could add obviously many other functions here down the road. You could imagine like stream processing functions. You could imagine data integration functions. There are all kinds of directions you could go, but this is basically allowing a developer to interact with and start discovering what's available. The other interesting pieces I have here is I have this OpenAI service class, and what this is doing, part of what it's doing is that basically every time it's going to be invoking GPT-3.5 Turbo, it's going to pass these function prototypes to the LLM. So the LLM is going to understand the structure of these functions, and we're telling it that it's a helpful assistant that can understand async API specifications and Kafka topics, and it's going to help the user do a bunch of things. Now, when the project starts up, it's going to fetch all the async API definitions from my catalog. It's going to index them, and we're using the async API parser, which is developed by the Async API project. Thanks a lot for that, Async API team. So it's parsing, extracting the channel information, the operations, the schemas. So we can use all of that as context when interacting with the LLM. And then we have a Kafka service here, which is using the Kafka JS client. So I think this is developed by Confluent. It's a JavaScript client for Kafka. And what this is doing is basically, if the LLM and the agent determines that the question the user is asking about is to get a message on a topic, where it's literally going to dynamically start a Kafka client at runtime and connect to the Kafka broker running on my machine and consume messages and start reading data from that topic. Okay, so we can have a go now and start this up. So I'll switch over here to my terminal. Let's maybe zoom in a little bit. And I'll start this node application. So this is going to kick off basically, and it says, okay, cool, agent initialized. You can now ask questions. So the first question I can ask is, for example, what are the topics available? Something like that. And so the LLM's like, okay, cool. The agent is passing this question to the LLM along with the context about the functions and all the async API information, and it's able to list back now a list of topics. Cool. So now I can basically say, what is the schema for the catalog burgers topic? And now same thing, it's going to invoke a different function, which is going to look up the schema that matches that topic. And I'm getting a slightly verbose response here, but basically you can see stuff like here, you can see the type of the burger is described, the calories, and whether or not it has pickles. And obviously, because we're using an LLM, we can also ask it to do a sort of a summary to sort of try and give me a human readable description of what it thinks this topic is about. So it's not doing the best job ever here, but it's nice to give you some sort of humanly readable documentation as opposed to just a schema. And so now that I've seen, okay, cool, I'd like to hear about burgers. I like burgers. Let's say, get me the latest message on topic catalog burgers. And of course, I'm phrasing this in a certain way, but there's no limit to what kind of way you can express this. As long as semantically the LLM gets your question, it's going to figure out that it should be routing this to the right function. So when I send that in now, okay, I get some interesting logs, but basically after a while, here we go, I've got a result, and you can see that it's literally gone ahead and read the latest message from the burgers topic. And you can see the parameters here. The type is a cheeseburger, pickles, true, awesome, I love pickles, and 147,000 calories. Sounds great. So if I were to go into my control center here and browse through the messages from my topics, you would basically see that that's where we're reading from. Very cool. So I think it's very exciting, basically, experiment to just show the power of LLMs and how by making smart little agents which are very focused on specific use cases, you can start really improving developer experience. And then sky's the limit in terms of what you could imagine doing after this, in terms of like stream. For example, can you calculate the average price of the orders people are making over time, and then you could generate a Kafka Streams query or some processing that will make a calculation for you. There's all kinds of directions you could take this in. So this is all, I guess you could say, a bit forward-looking, but we're not far from really having these kind of experiences in developer portals and catalogs, and that's some of the stuff we're thinking about here at Gravitee. But in the shorter term, there are some other things that we're looking at, because we're talking about Kafka here. We speak to more and more companies that basically are looking to API management platforms to provide similar capabilities that we provide for REST APIs, but for things like Kafka topics and streams. There are a lot of challenges around managing costs when it comes to Kafka, like expensive services for hosting. The developer experience is challenging, as we described. Security and access control is not always easy, especially if you want to expose Kafka to the outside world, for example, which has almost been unthinkable until recently, as I'll tell you in a second. And challenges around governance and operational control. Basically, it can be total chaos in a lot of companies. Anyone can create topics, anyone can store data, and it's very hard to gauge an understanding of who's writing what kind of data where, and basically what's going on in your Kafka clusters. So that's why Gravitee just recently launched the Kafka Gateway. So it's a new type of gateway which can proxy the Kafka protocol natively. So you have a Kafka client on one side that's consuming a Kafka cluster, and you have a Gravitee gateway sitting in the middle, which is able to intercept that traffic and apply some policies just like you would for a normal REST API. And the great thing is, at Gravitee, we use the same gateway, basically, which is able to process REST APIs and also Kafka native APIs, and we can apply policies like rate limiting, transformations, topic routing, virtual topics, all kinds of great stuff that are very valuable when you want to address some of those pain points I just mentioned. So that's a very exciting piece that we're working on here. And basically, with this, customers and companies are able to expose their valuable Kafka data to customers, to consumers that are sometimes even outside the organizational boundary, because we're able to add that level of security that you require to do that. So for a lot of people, it's basically unheard of to do this, and it's really becoming a reality today. So just to wrap up, I think it's interesting to look at like the evolution of basically, the digital transformation and how companies across all industries have had to think about software and technology. In the 90s, you had to have software, basically, you had to create a software version of your business to survive. In the 2000s, you had to create an API for your software so they could interact with other software, with the outside world, with developers. In the 2010s, we iterated on this. Now APIs had to be well documented. They have to have an SDK, a CLI. You have to be able to do infrastructure as code. And if you look at the 2010s, I think the big basic pressure on organizations and companies is going to turn into making sure that your systems, your APIs, can be consumed by AI agents. That's going to be one of the new interfaces to software is AI agents and LLMs. So they need to be able to consume your systems. So if REST APIs are being described by OpenAPI and those are consumed by AI agents, I think the same thing is basically likely to happen for event-driven systems, and hopefully AsyncAPI can play a very important role in describing those systems and making them consumable by AI agents. So that's it from me. Thanks a lot. We had a great event overall. Thanks to all who dropped by the booth. We had a lot of fun with our electric car game that was actually implemented using Gravitee as well to do the scoring and everything. So that was a lot of fun. I'll hope to see you again soon at another conference. Thanks a lot, and I'll see you next time. Bye-bye.